Hello, my name is Jim Wenkowski. I am a Principal Solutions Advisor with Rocket Software. In this short video, I will be giving an overview of IBM's Data Virtualization Manager for z/OS, as well as walk through a live demonstration of how to virtualize both VSAM and IMS objects. So let's go ahead and get started. So let's start by understanding exactly what data virtualization is and what the DVM for z/OS product is going to provide. So data virtualization is a data access methodology that presents data in memory in a relational format for consumption without the consumer having to have knowledge of where or how the data is stored or formatted. It provides a data services layer between the data source and the application, providing data in real time, eliminating the cost and complexity of having to do the traditional ETL processes. So data virtualization is going to shield the end user from having to have specific knowledge of the data source being accessed. So virtualized objects are stored in a metadata catalog which resides in memory on the DVM server, providing a common relational structure regardless of the data source. So DVM is not only going to provide that real-time read capability across multiple data sources, but it's also going to support full write back and update capabilities across the majority of your different data sources as well. Also new to DVM now it is also integrated with the IBM watsonx Data Lakehouse via a Presto DB connector. So let's get in and talk a little bit about the architecture of DVM. So before we get into the demo, I'd like to give you a bit of an understanding of the basic architecture of Data Virtualization Manager. So Data Virtualization Manager is a started task that runs on z/OS. So it is the only 100% z/OS based data virtualization tool on the market today. So in the middle, what you're looking at is you see that is the DVM server, again, running on your z/OS LPAR. And some of the basic components that you have within the server, number one is our SQL engine, which allows you to do the virtualization and conversion of the various data sources. The metadata repository resides in memory within the DVM server. The metadata repository contains the mapping criteria in order to convert the SQL calls that you're going to be submitting against the various data sources into the native underlying data source access method. So essentially the way that works is we will be mapping a COBOL copybook to the underlying data structure, allowing it to have a virtual or relational rather type of structure, look and feel that again allows you to run that native SQL. For high data volumes, for doing large data pulls, we have MapReduce and parallel I/O technology built into the DVM server. So for large queries, what we'll do is we'll break the query up into multiple parallel tasks that run concurrently and bring the data back. So allowing you again to very efficiently bring back large volumes of data. The other thing to note is that we heavily leverage zip technology on the mainframe. So much of your I/O can be offloaded, up to 98+% can be offloaded to the zip engine, saving you on your general processor costs. So on the left, you see the data requesters that are supported by DVM. SQL, RESTful API calls via integration with z/OS Connect, NoSQL, SOAP, as well as native z/OS. This allows you to integrate these different data sources into your modern BI applications. There are cloud mobile apps, enterprise data lakes, enterprise data warehouses, as well as z/OS resident data consumers such as DB2, IMS, MQ, Kix, as well as Spoofy. So with that, let's go ahead and move forward and walk through a live demo of virtualizing some data sources. Okay, so what you're looking at here is the DVM Studio. This is really where you're going to be doing the majority of your administrative work when it comes to virtualizing your objects and doing various other management features. What I'm going to do is I'm going to walk you through a couple examples of how to virtualize different data sources. I'll walk you through an example of VSAM as well as IMS. Before you can start virtualizing, one of the first things you have to do is you have to set up some of the source libraries that you're going to be using, and you'd be doing that under the admin task here. So we're going to go ahead and we're going to expand that admin. And you'll see here that you've got your source libraries. And within your source libraries are where you need to define, number one, your COBOL copybooks, right, that contain your relational structures for the data sources that you're going to be virtualizing. And also in my case, because I'm going to be doing some IMS, you'll notice that I've also got a DVD source lib as well as a PSB source lib. And if I right mouse click on these and I go ahead, I'm just going to click to edit, you can see that this is just a PDS that I have on my ZOS platform, my COBOL copybook, and then also as well my DVD source as well as my PSB sources. So again, when you first come in here, what you do is you come in here and you'd say create your virtual source library. Say you want it to be a data set, give it your name, your library name, and then just click finish. And as you can see, I've already got all those defined, right? So I'm ready to go. So let's go ahead and start virtualizing. So I'm going to go up here and you'll see I'm connected to my server. My DVM server is called AVZB. When I click my set server, you'll see here that I've got different DVM servers in different locations, different LPARs. I'm using this one called AVZB. So once I'm connected, I will go over here to the SQL tab, and I'm just going to start breaking this down here, expanding. I go data, there's my subsystem. DVSQL is the default schema that you will use for your virtualized tables. We do give you the option to create a custom schema, so you may want to create multiple schemas. Particularly if you're in a production environment, you need to segregate your virtual tables based on schemas. You can do that very easily with the Studio. But for this example, what I'm going to do is I'm just going to go in here to my virtual tables. And what I will do is I'm going to right mouse click on virtual table. And I want to say create a virtual table. So I'm going to go ahead, I'm going to do the create. And again, I'm going to start out with a VSAM. So I'm going to go ahead and click VSAM. I'm going to click next, and I'm going to give it my name. So I'm going to call this just VSAM VT. I can give it a description. So this is a sample VSAM virtual table. This map library is where this is your metadata catalog, essentially data set. This is defined in your server task. So when we define our virtual table, what we're doing is we're mapping the data source to a COBOL copybook. That map will be stored in this data set, and then when you start up your server task, this data set gets loaded into your server, and that is what's used in order to convert your virtual table into the native calls of whatever the data sources that you're pulling in. So I'm going to go ahead and just click next. The first thing it's going to ask me for VSAMs, very simple, is it needs the copybook. I can have multiple copybooks out there, so you'll see I've got different versions of copybooks out there. So I can select the copybook that I want to use, and by doing that, on the left here, what it'll do is it'll bring up, these are all the members in my copybook, as well as over on the right, these are ones that I already downloaded. So if there's a new one over here that I need to download. So if I want to go back to this first copybook here. So we're going to be using this one called symbols. So I would click on that and I would say download, but in my example here, I've already got it downloaded. So I'm just going to check it and I'm going to click next. And here is basically my copybook. So I can open this up and review this. So you see this is a very simple example here of a copybook. So I'm going to go ahead and click next. The next thing it's going to ask me for is what is my VSAM cluster name, and I have that that I copied out. And again, so this is my VSAM data set on ZOS. I would click validate to ensure that this is a valid name and that it's a valid data set. I'm going to click OK, and I'm going to click finish. And that's really all there is to it. I have now created a VSAM, a virtual table against a VSAM data source. So you'll see here, if I scroll into my tree of virtual tables, there it is. I can expand it, and you'll see that, again, this is a very simple example where I've only got actually 2 fields. If I want to run a query against this, it's just a matter of I can do my right mouse click and I'm going to select generate query, and I'm going to go ahead and execute that query, and there you go. I just queried my stock symbols VSAM file here, so you see I've got different stock ticker symbols with the company name. So again, that's how easy it is to virtualize a VSAM data source. So let's go ahead and go back, and this time let's go ahead and now I'll give an example of creating a IMS data source. So in this example, I'll go back to my virtual table. I'll say create virtual tables. In this example, I'm going to select IMS, and I'm going to go ahead and I'm going to click next. And now, remember, we defined those DVD and PSB libraries down under the admin section. So that's what these are. If it's my first time in here, I'll need to click the extracts again to download these into the DVM Studio, just as I did with the COBOL copybook. But my example again, I've already got my DVDs and PSBs downloaded. So I'm going to go ahead and drop this down and pick the names I need. So my first one, my DVD is called DI21 part. I've got a PSB out there, and that PSB is this DFSS AM09. Now I'm going to go ahead and I'm going to say create a virtual table. In this example, I'm going to say IMS VT. And again, I can optionally give it a description. All right, so I'm going to go ahead and click next. And again, it's going to ask me for my copybook. So my copybook name is, let me scroll down in here, is this stand info. I'm going to go ahead and click next. Again, I can expand my copybook. So you see here my copybook definition that I'm going to be applying to this IMS segment. I'm going to click next. The one other field that it's going to ask me for is what my segment name is. And for this particular one, my segment name is the same as my copybook, called stand info. One of the other options you have in here is how you access your IMS data. You could do standard IMS DB control, or DVM provides something called IMS direct. This is if you're going to be doing read-only selects and you're bringing back very large result sets, so doing large data pools. That's what this is very useful for, and what that does is it goes around the IMS engine itself and goes directly to the underlying data sets and reads directly from the files. So that way you don't have to go through all the mechanisms of IMS to retrieve your data. So it's very fast, very efficient. So we're going to go ahead and we're going to click Finish. And we are now creating a virtual table against an IMS segment. And we're going to go ahead and click Finish on that. And you'll see there's my virtual table for my IMS segment. And I can expand that. So again, look just like as a standard relational data table. So again, I could just do my right mouse click, click Generate Query, go ahead and execute, and now I just ran a query against that. So those are just a few simple examples of how easy it is to virtualize different data sources. The other thing to note is that you can also optionally create virtual views, and within the virtual views you could actually join different data sources. So example that I have here, if I go over here into my virtual views, I have an example within here where I'm actually joining a DB2 table to a VSAM file. So if I go ahead and I do an edit on this particular view, you can see I've got a simple join here where I'm joining my VSAM table to a virtualized DB2 table that I can then run again, just as if they were the same. It just like I'm joining them just like I would if these were all DB2 objects or any other relational database. So then I can run my query, right, and actually then run against that joined file. So now I'm retrieving data actually from both a DB2 table and a VSAM file in that join. So you see it's very powerful. DVM allows you to join these different data sources, makes, no matter what the structure of those data sources are, makes them all look like a common relational structure. Again, making the data very accessible, and essentially shielding the developer or the end user from the nuances of the actual data source. So hopefully this short video gave you a good understanding of exactly what Data Virtualization Manager can provide and the benefits of being able to access data in real time versus having to do expensive data replication processes. Again, DVM allows you to use common SQL calls and leverage modern APIs such as JDBC, ODBC, as well as REST without having to understand the nuances of the various data sources, providing a very easy, quick methodology for allowing developers to build modern applications throughout all the and leveraging and integrating all these different data sources. Well, that ends the overview of IBM Data Virtualization Manager. I hope you found this video informative, and thank you for taking the time to watch.